A, B, and C are these three angles of a triangle, so the angle sum is 180 degrees. Let's let x, y, and z be 3 times these angle measures. So we have that x plus y plus z is 3 times pi. Let's start with the angle that they give in the problem statement, and we'll substitute x, y, and z. We'll solve this equation for z and make this substitution down here to get rid of one of our variables. So this is the cosine of 3 pi minus x plus y. We can simplify this by noting that the cosine of 3 pi is the same thing as the cosine of pi. So now this is the cosine of pi minus x plus y. And we remember that an angle and its supplement have opposite cosines. So I'll replace this with minus cosine of x plus y. I have the sum of 3 different cosines here on the left, and I can also write 1 as a cosine. So let's add this cosine of x plus y to both sides. And cosine is 1 when the angle is 0. Now I'm going to use a sum product trig formula that's easy to derive. We'll start with the cosine sum formula. That's cosine cosine minus sine sine, and the difference formula, cosine cosine plus sine sine. We'll add these two equations. These terms cancel, and on the right-hand side, we have 2 times the cosine of p times the cosine of q. Now let's let alpha be p plus q, and beta is p minus q. Alpha plus beta gives us 2p, and alpha minus beta gives us 2q. And we'll substitute here. This is cosine alpha and cosine beta, and on the right-hand side, we have 2 times the cosine alpha plus beta over 2, and cosine alpha minus beta over 2. And this is the formula we're going to use on both sides of this equation. We'll start with the left-hand side. The sum of cosine x and cosine y is this expression on the right, and we'll do the same thing with the right-hand side of this equation. This is 2 times the cosine of x plus y plus 0 over 2, and cosine of x plus y minus 0 over 2. We have that the left-hand side is equal to the right-hand side, so we'll set these two products equal to each other and divide by 2. We have 2 cases where these products are equal to each other. One of them is if the cosine of x plus y over 2 is equal to 0, or if the cosine of x plus y over 2 is equal to the cosine of x minus y over 2. Let's look at case 1. This cosine is equal to 0 at a multiple of pi over 2. If we return to the beginning of the problem, we have that the sum of x plus y plus z is equal to 3 pi. This means that x plus y is strictly less than 3 pi, and these are positive angles because they're part of a triangle. Dividing this chain inequality by 2, we have this upper bound on x plus y over 2. It's strictly less than 3 pi over 2. Combined with this, we have that x plus y over 2 is equal to pi over 2, and x plus y is equal to pi. Again, x was equal to 3a and y was equal to 3b, so substituting, we get a plus b is 1/3 of 180 degrees, or 60 degrees. So by angle sum, we have the third angle, c, is 120 degrees. Let's look at case 2. In order for these cosines to be equal, we must have one be equal to the other plus a multiple of 2 pi, or they can sum to a multiple of 2 pi. Looking at this first subcase, we'll multiply by 2 and combine like terms. So y is a multiple of 2 pi, and since these 3 angles sum to 3 pi, y is also a positive angle that's strictly less than 3 pi. Combined with this above, this means that y is equal to 2 pi. Substituting for b, this is equal to 2/3 pi, or 120 degrees again. Let's take a look at this last subcase. By summing and combining like terms, x is also a multiple of 2 pi, and again, x is less than 3 pi, which means that x is equal to 2 pi, which again means that a is 120 degrees. In all 3 cases, we have a triangle with an obtuse angle equal to 120 degrees. This means our other 2 angles are acute, so our longest side is going to be opposite the 120 degrees. So our triangle looks something like this, with side lengths 10 and 13. We can find this third side length using the law of cosines. The square of the side length is 399. So s is the square root of 399, and they want us to find m, so our answer is 399. If you'd like me to solve any other math contest problems, please leave them in the comments.